This is a Blender Python tutorial where we'll be going over how to implement this animation using a Python script in Blender. Hey, I'm Victor Stepanov. I'll be guiding you through this Blender Python tutorial. Today, we'll be creating an animation using the Phyllotaxis pattern or the sunflower pattern. I'll be creating a version of the animation that you see on your screen. It was originally inspired by Dan Shiffman's tutorial on Phyllotaxis. We'll be animating the strength of an emission node, and also we'll be working with the depth field of the camera. Let's jump into Blender and get going. We're going to be using some helper code to start off and start quickly iterating on our script. So I've provided a link in the description under Start Code. Open that link in your favorite browser, hit Raw, select that code, and copy it. Now in Blender, go into the scripting workspace, and then hit New right here, and then paste in that code that you just copied. This script just clears the scene, adds a camera and an empty that the camera will track. Let's run the script and see what it does. So I just ran the script, and you can see that there's only this camera and this empty right here, and that is it. And again, if we modify anything in the scene and if we run the script again, it's going to reset everything as it was. Before we continue, let's make sure to save our project. So let's go into File, Save As, then go into a folder that you want to save your project in, and then just save it under a name that you think is appropriate. I'm going to just use Toot, and also I'm going to save this script as well. I'm going to save it in the same folder, call it toot.py, and save it as well. So make sure that's all saved before we continue. Okay, the first thing that we need to do is we need to place the icospheres that we'll be using in our scene in a Phyllotaxis pattern. We'll be using a formula out of this book. In this book, there's a formula that will allow us to place the icospheres in this pattern. I've created a separate video going into the details of how this formula works. So if you want more details, make sure to check that video out. Let's go into the create centerpiece function and start implementing this formula. Let me copy some comments right here to explain where you can find this in the formula. These are the constants of the formula that won't change while we're creating the pattern. Now we need to create a for loop that's going to calculate the points in our Phyllotaxis pattern. Let me copy some more comments here to make things easier to read when we come back to the script. The primary idea of this formula is that we would go around the circle and then change the radius, and that would make this pattern appear. So we're calculating a new angle, or calculating a new radius, and then transforming the polar coordinates into the Cartesian coordinates with this formula. And this gives us an X and Y that we can use in Blender and put our icospheres into the scene. Now let's put the icospheres into the scene, and to get that we need to get the command for retrieving icospheres through Python. And to do that, we're just gonna do this by hand, hovering over the 3D viewport and hitting Shift A, then Mesh, and Icosphere. Right here in the info panel down below, I'm just gonna copy this code that was added as soon as I added this by hand. I'm gonna copy it like so, place it there. We're gonna update this radius in just a second. We don't really need anything except the location and the radius. We won't be using the scale parameter here. In the location, we're going to put X and Y, the thing that we just calculated in the previous two lines right here. And this, I'm going to go up, and above this, I'm going to create icosphere radius. I'm just going to use this right here so we can control the radius if we ever wanted to change this in the future. This should be in a good position to let us run this script and see what happens. So I'm going to go up here and hit run, and let's see. And if we zoom in right here, we can see that we have our pattern already appearing. That's great. Go back. By the way, I'm hitting Control Space to make this 3D viewport full screen. To make this more readable, I want to move this calculation into a separate function. So I'm going to select all of this and just cut it by hitting Control X. Then going up here, paste it, unindent it, and create a new function. Okay, with this function definition, I'm gonna move this call right here. We're gonna be returning X and Y out of this function, so I'm gonna set that right there. Then we need to return this X and Y here, and we need to pass in the N, the angle, and the scale factor. All right, let's see if this all still works. Run it. Oh, yeah, of course. Now I need to pass in all of these down here, right? All these parameters. Now let's run it again. And as you can see, there's nothing in the scene right now. I'm gonna run it. And okay, this still works. That's great. The next thing that we need to do is assign an emission material to every single one of these icospheres. So let's do that. I would need to get the currently active object. As soon as we add an icosphere or any other object into the scene, it becomes the active object, and I'm getting the reference to that active object. And this function right here is a helper function that's defined above in the helper function section. So above somewhere here. I won't go to there just now, but trust me, it's there. You can look it up. Next, we need to create our emission material. And to do that, we have a special helper function for that, and it's called create emission material. Now I'm going to go up and copy that for us. So it's this right here. I'm going to just copy this and then head down right here and then paste that in. And let me make a bit more room here so we can see all the parameters. And the thing that we will be returning from this function, as I scroll up again, is I want the material and the nodes. So we would need the material to actually assign this material to our active object, and the nodes, this will allow us to animate the emission node. Let's do just that. So I'm just going to copy this, and also I'm underlining that we would need to set this return nodes to true, because you can kind of have two versions of what this function can return. And I'm just going to use the return nodes since we are going to be animating this today. Also, all of this helper code, or most of this helper code, you can get for yourself without having to copy around this code. I'll show you how to do this in the end of this video, so make sure to stick around until the end. And let's update the call site. I'm going to paste that in. And I'm going to change this to true. I'm going to set the name something that I think makes sense. I'm going to use N. So this is, since we're going to be generating a material for every icosphere in our scene, I'm going to be using N to differentiate if we ever want to see what's wrong with a particular icosphere's material. We'll see this right here, and we'll be able to kind of reference it. But hopefully we won't need to do that today. And for the color, we're going to be using color that I'm going to define up here. I'm going to copy the Python logo colors. So I'm creating a tuple, and these are the hex codes for the Python logo color. And I'm using a special helper function also defined above to convert these hex code colors into something that Blender can understand. These helper functions I also explained in another video. If you're interested in how I did that, check that out as well. And now I'm just going to copy this, and I'm going to go here, and I'm going to write, and I'm going to be using the choice function in the random module, which allows us to randomly select either this or this color. So let's see how this right here looks. So we have the energy set to this 30. It doesn't really matter because we're going to be animating this in just a minute. We're returning the nodes, we're setting the name, and we're setting the color. All right. Now we need to assign this material that we just created. So we're going to append to the list of materials of the currently active object, and that looks right. Let's see if I got everything right. I'm going to go into the interactive Python console, and I'm going to hit Z, and then you can see that nothing is emitting any light. And we're going to fix that by assigning this emission material in just a second. So I'm going to hit run, and let's see what that did. And you can see that now we have this emission material randomly applied to every single one of the icospheres in our scene. Great. Now it's time to start animating the strength property of the emission nodes. And before we do that, let's modify our workspace so we could see the timelines, so we can see that we're actually adding keyframes. I'm going to pull that up. I'm going to add a timeline. Hide that. This. All right. Okay. Right now, if we play the animation, nothing is happening because we haven't started to add any keyframes. We're going to be doing that in just a second. Next, we need to find the correct data path for the strength value or the strength property of an emission node. I'm going to go into the shading workspace, and as you can see, we're selecting one of these. Yeah, here we're selecting this icosphere, and you can see there's a single shader node right here. It's the emission. It has a color and a strength, and we need to animate this right here. So I'm going to change this, and as soon as I change it, I can go back into the scripting workspace and go down here, and here's the code that modifies this strength property. I'm going to copy that. I'm going to paste it down below right here. I'm going to actually move this a bit like so. Instead of using all of this right here, we can just use this node. So nodes, I'm going to select that. All of this is the same thing as writing just nodes, because remember we're returning the nodes. It's exactly a reference to the nodes in the node tree of the shader node graph. So that's emission. And inputs, you can use this number if you go back into the shading workspace. So the color is 0 in the inputs, and then the strength is 1 because Python lists start with an index of 0. I'm going to go back, and actually you can use text version of this as well, and it will work just fine. Like so. Okay, now let's set this to 0. So remember, after running this create emission material, we're actually setting the initial energy. You can look into the helper function to make sure that's getting set. It's getting set to 30, but right after I add this material to our icosphere, I'm going to set the current value of the strength to 0. So it's going to basically just turn everything off. So let's try that out. Run it. And now you can see that we still have icospheres here, but the energy is set to 0. Let's make sure that we're actually assigning the materials. I'm going to go into shading, and as you can see, we do have an emission node here, but the strength is set to 0. So see, that assignment is working. Now let's insert a keyframe at the very first frame. I'm going to use this and then call the keyframe insert function. So the very first parameter that we need to pass into this function is the data path, and that is going to be this default value. And then we need to provide the frame where we're going to be inserting the keyframe. And I'm just going to set this to 1 for now. Let's run this code. Okay, the script finished running, and you can see that we have a keyframe at the very first frame. Now let's do this. Now let's add another keyframe at the very end of our animation. So I'm going to just copy this. I'm going to paste that in. So the way that our animation is going to work is we're going to start the strength of the emission node at 0, and we're going to finish it at 0 as well. And then we're going to have some mid value that we're going to be animating towards. It's going to go up and then down. So I'm going to just set the final keyframe as well. The frame there, I'll use 60. So 60 is going to be the length of our loop. And now let's run our script and see how it adds another keyframe at frame 60. All right, you can see that we have another keyframe set at frame 60 right here. And now we need to add another keyframe in the middle of that and then set that to mid value of whatever we want the emission strength to be. I'm going to set the emission strength to be 20. And I'm going to set the frame to 30. And let's execute this script. Okay, now you can see that we have the 3 keyframes inserted. I'm going to press space, and you can see straight away that all the emission nodes are animated, right? So I'm going to continue, and then they're off, right? So there's on and off. Now I want to organize these values, the start, the middle, and the frames in a better way into variables right here. So I'm going to create the start emission strength, right? And I'm going to use it as the first initial value right here. I'm going to move this right here so we can see. And I'm going to move it. I'm going to use that variable at the very beginning and at the end of our loop here. I'm going to copy this and replace it with the mid value. I'm also going to use the current frame for this right here. Now I want to calculate the mid frame using this current frame. So I'm using the current frame, adding half of the loop length, and using this mid frame right here instead of this 30. And let's calculate the end frame as well. And I'm just gonna add the loop length to the current frame and use the end frame right here. Okay, that looks right. Let's see if everything works as it did before. I'm gonna run the script. And I need to check my spelling of loop length. And I think that is everywhere where I used that. So let's run that again. Okay, it looks like everything still works. So yeah, it's going off and on. Perfect. Now we need to offset the start of the animation on each one of these icospheres. And to do that, we'll need a new variable up here and call it frame step. And I'm gonna change the current frame on each one of the iterations of this loop and use this frame step right here. Note that this frame step is a decimal point number. It has a decimal point, and we don't really have decimal points in frames. This is more to slow down the progress of this wave. So if you increase this, you can play around with it and see how the wave will go faster. So I'm going to just set it to 0.5, and you'll see how that looks in just a second as I run this script. Okay, the script finished running, and you can see the keyframes have shifted to the middle of our timeline. This means that we are offsetting the start of the animation. So let's see how that looks if we play the animation. And now you can see we have this wave pattern. All right, let's reset that. Go back into the full screen. I'm going to hit a 0 on my numpad, and this will show how this looks from the camera point of view. And you can see right now this is very out of focus. This is done on purpose. In the setup function for the camera, I've set the depth of field in this way. I'm going to modify this in just a bit so we can see a better view. I'm going to go up where I'm defining the camera, and I'm going to just copy this. So I'm going to leave it as so in the setup camera function, and we run that function in the scene setup. I'm just going to modify it here. We'll be animating this in just a minute, but I want to show you how this would look if there was a slightly less depth of field effect. So I'm going to save that and then run the script again. Okay, I'm going to go back into the 3D viewport, hit Control Space, and I'm going to go into the camera view. So I'm going to press numpad 0 and then play the animation. All right, this looks slightly better, but we still can do some more with the depth of field animation. Before we continue, I want to organize our code a bit better, and I want to replace this with a function call. Actually, I have a helper function that does exactly this, and it's right here. This function right here. I'm going to copy it. It really does the same exact thing as we're doing just down there, but it does it in a slightly more fancier in a general way than what we're doing down there. This could be reused for other types of animations as well, just providing the object that we'll be animating and the data path, and then setting the value to a start value, then setting the start value again at the very end. It's literally doing the same things, but in a slightly more general way. Let's use this function right here. I'm going to paste in that. The object in this function will be this, so it's the input's strength. Then the default, the data path, sorry, is going to be this default value. The start value will be our start emission. The mid value is going to be the mid emission strength value. The start frame will be the current frame. So we're going to use that right here. The loop length is going to be the loop length, that one that we already defined here. And I don't want the linear extrapolation of the F curves. I'm going to set this to false. And let me comment this right here. I'll just select it, hit Control /. I'm going to select it one more time because we need to indent this like so. And now let's run our script again. Okay, this script finished running, and it looks like it has the keyframes in the right place. Let me check that once more. And yes, everything is working as it did before. This is great. And if you are comfortable with the syntax inside of this function, then just go ahead and use this helper function going forward. If you're not comfortable, it's totally fine. You'll have time to learn all these aspects of Python, and just use this more simpler and easier to read syntax right here. I'm going to be just removing this for myself, but it's going to be your call to, or whichever you want to use, because it's doing the exact same thing. All right, next I want to update the number of frames that we're using in our animation. Right now we're setting the frames to 360. This is done right here where we're setting up the scene. So we're setting the FPS to 30. We're setting the loop length to 12 seconds. And then we are putting the frame counts here and then the FPS right here. And the end frame is set right here in the scene props. It's another function just above. So we're calculating the frame count right here, and we're using this this right here to set the end frame. Let's update that right after we finish looping over our for loop here. I'm gonna just move that like so, and I'm gonna set the current frame as the end frame, and let's see what happens when I run this. And we get an error, and it says that the frame end is an int type, not a float. This means that we can't assign a floating point number to this end frame property. And the reason why this is a floating point is we're adding this frame step, which is a floating point with a decimal point right here. And after doing this addition, this turns into a floating point. So we need to turn that back like so, and then run our script. Okay, the script finished running, and you can see that we did update the length of our animation, but now it's kind of cutting off at the very start of our final icosphere. Let's see how that looks in this full screen view. And you can see it just cuts off right there. It doesn't look nice. The reason is that we're not accounting for the loop length, and to do that we just need to add the loop length like so. So let's just do that. Okay, now all the keyframes that we are adding are in our animation. Let's play that. All right, that loops nicely. This is great. This is exactly what we wanted. This looks a lot better, but we still have an issue. If you look at the end frame, it's 211. This doesn't evenly divide into 30 frames per second. We need to fix that. To get the correct end frame, we're going to be using a div mod to get the quotient and the remainder. Let's go into the interactive Python console right here, and let me show you this. So div mod will give you the quotient and the remainder. Let's do this operation with 211 frames and then divided by 30. So we're targeting 30 frames per second. And you can see that if we multiply 7 by 30, we'll get 210. So that would be, if that was our last frame, then that would be 30 frames per second. But we still have 1 in the remainder, so it's not quite that. So if I just add 1 to the quotient, I'll get 240 frames. In some sense, you could just drop this maybe 1 frame, maybe it won't be noticeable, but I just want to be safe, and I just want to add 1 to the quotient and get the new frame count this way. Let's update our code right here. So I'm going to use the current frame. And then in the context, we have the FPS that we're using for this particular script. And this context right here is a dictionary. We're passing it in right here. And we're creating this context in the setup scene. Remember, I showed you just a couple of minutes before that we're creating this context right here in the setup scene, and we're just using whatever we have here to calculate the correct value for our end frame. So let's go back and let's use this quotient. So +1 times the FPS. Actually, this should be plus our loop length. Okay, now let's see how this works. And I'm stepping into the same problem. This should be an integer. Maybe I will figure this out by the end of this tutorial. Yes. Okay, let's do that again. Okay, there we go. Now we have the end frame set to 240. This is exactly 30 frames per second. This is what this code looks like now. Okay, let's move this into a separate function. All right, so we need the context here, and we need the current frame. And actually, let's create a if statement here. If the remainder actually isn't equal to 0, then we're going to do this calculation. Else, we're just gonna, if the remainder is 0, then it means that we can divide the current frame count in 30 into whatever frames per second we've selected. So we don't really have to do this calculation if the remainder is 0. Let's update the call site here. All right, let's save that and try to run this. All right, it looks like everything continues to work. This is great. And if you're learning something new or just enjoying this tutorial, make sure to give this video a like. I'll greatly appreciate it. And for the final touch, I want to animate the depth of field of the camera. This property right here. So if I select the camera and I select the camera properties, depth of field, and I would like to animate this right here. Let's move this like so we can see what this does. So let's, as you can see, as I move the focus distance, we have this effect going on right here, and I want to animate this here. And as soon as I modify this, I get this command right here that I can use in our script. So let's start creating a function just to animate this depth of field property. We'll be using the same function as we did right here to animate our strength of the emission node. And I'm going to just use this right here. So the length of our loop is going to be the end frame. I'm going to be passing in that value as a parameter. The start of the loop is going to be on frame 1. So let's update this, and then the loop length is that. The start focus distance is going to be 15, and the mid focus distance is going to be the current position of the camera on the z-axis divided by 2. And to get that, we would need to first get the data of our camera. And let's go into the interactive Python console and get that. This is going to be the camera data. And in particular, we're interested in the location and then on the z-axis. So right now it's set to 80. And just copy this, paste it here. Oops. Copy that. And we're going to divide that by 2. Next, we're going to use, I'm going to move this back. Can't really use this because this refers to the currently active object, and this is not going to be the case at the very end of our script because the last thing that we would have as the active object is one of the icospheres, right? So we have to explicitly say that which object we're going to be referencing. And in this case, we're going to be referencing the camera, and then using this depth of field right here. So we're not going to be animating the strength. It's going to be the depth of field, and the default of the path, the data path that we're going to be animating is the focus distance right here. So instead of the default this, I'm going to replace it with the focus distance. I'm going to clear this. Also, I need to update the start value for the focus distance and the mid distance. Now let's clear this and call function. I'm going to go at the very bottom and I'm going to call our new function, and we need to pass in the final frame, and we'll need to update our calculate our frame right here, this function. We need to return that value. So from here, we're going to be returning this because we calculated here. And also, you know what? I'm going to rename this. I don't like this name. It's going to be end frame. Like so. So end frame, end frame. All right. That looks like it's correct. Now let's run the script and make sure everything is working. Okay. We didn't have any errors. Let's see how this looks from the camera's point of view. I'm going to play the animation. And it's not quite as defined as I wanted to. And I think I modified this setting right here. So we don't need that anymore. It was just for demonstrating before. So I'm going to save that. I'm going to run the script again. Okay, let's do that again. Control space over the viewport, 0 on the numpad to see a better view, and press space to play the animation. All right, this is exactly what I was looking for. Perfect. All right, there's actually one more thing that I want to update, and in the create centerpiece function, we can actually use a random uniform here to have random patterns appear each time we run the script. And it's going to go from 137 to 138. And now each time we run the script, we're going to get a slightly different pattern. As you can see, it's different than it was. And if you like the previous pattern, the sunflower pattern, you can just hard code this value right here instead of doing this random uniform call. And before we go, I want to show you where you can customize this script. So I'm using just 2 colors here. Make sure to experiment with different colors, maybe some color palette that you really like. Experiment with the camera angles. So at the very top in the helper function section, we have the location and the rotation of the camera. So you can experiment with that. Also, make sure to experiment with the different values in this formula and the loop length, and see what works for you. Maybe you don't want the depth of field animation. There's a ton of variations that you can use to see and generate something new. And if you do create something, make sure to post a link in the comments. I would love to see what you created. And for the final thing in this video, I want to show you how you can generate the same scene without having a number of helper functions. I have a special Python package that's called BPY building blocks, and it has a number of these helper functions already defined, so you can reuse them in your own scripts without having to copy around code. To get this Python package, just go to cgpython.com/bpybb. This will redirect you to a GitHub page with the latest release of this Python package. Scroll down in the assets, there'll be a zip archive that you'll need to download to your machine. After that's done downloading, let's install this add-on. Go to Edit, Preferences, and then Install. And then let's go into the downloads or wherever you downloaded that zip file. Select that zip file and install. And make sure that you don't have any other previous versions of this add-on enabled. So if you have been following along in my previous tutorials, you might have installed another version. So make sure you have the latest one and click this checkbox to enable it. This will enable the Python modules that we need. So now we can go back and we can comment out a number of lines of code. So I think from here, just comment this out. So none of this code exists. And if I run the code now, it's not going to work. Now I need to copy the imports of functions from the new modules that we've enabled. Here they are, right? So you can see we have the BPY BB Python module, right? Python package, and then it has modules inside with different functionalities that we're using, like clearing the scene, for example. And I don't think we need this. And let's run our script. Okay, you can see that our script still works. All of this code is commented out and basically means that we can just save a lot of lines or a lot of space in our script and just have these functions hidden in these imports right here. All right, I hope you enjoyed this tutorial. For more tutorials like this, make sure to subscribe. Thank you so much for watching.